It is important to understand what state the refrigerant will be in at any point in the circuit. If refrigerant can be identified as being in the incorrect state at any part of the circuit, this will have almost certainly led to a failure of the system and possibly damage to its components. Air conditioning systems work by use of a sealed circuit that regulates the pressure at different locations within the circuit to facilitate a refrigerant state change. It's this state change that either assists the removal of heat from the cabin or the expelling of heat to the external environment. The refrigerant circuit is split into 4 phases. The circuit starts at the compressor. It absorbs the gaseous refrigerant with a low pressure, 1 to 2 bar, and low temperature, approximately 0 degrees C, and compresses it to a gas with a high pressure, approximately 15 bar, and high temperature, approximately 80 degrees C. The compressed gas is then transferred to the condenser. The heated gas entering the condenser is cooled by the air circulating around the cooling fins. When the gas has cooled down to approximately 20 degrees C, it begins to liquefy. It is then in a liquid state, but it still contains gas constituents at the condenser outlet. Receiver or dryer. The liquid refrigerant flows into the receiver dryer, where the gas constituent is separated from the liquid refrigerant. The refrigerant is kept in the receiver dryer until the required amount of cleaned, contamination and moisture-free refrigerant is extracted. The liquid refrigerant is then transferred to the expansion valve. When it passes through the expansion valve, the liquid refrigerant is converted to a mist with a low pressure. The refrigerant which has entered the evaporator evaporates by absorbing heat from the air entering the occupant's cell. There are 2 types of component that allow for the reduction of pressure and thus the change of state from a high-pressure liquid to a low-pressure gas. They are flow resistor or fixed orifice tube type and thermal expansion valve or TXV type. The refrigerant, which has entered the evaporator, evaporates by absorbing heat from the air entering the occupant cell. The temperature rises to approximately 5 degrees C at the evaporator outlet. On leaving the evaporator, the desired outcome is that all the refrigerant is fully evaporated and returned to a gaseous state. On systems with a flow restrictor type expansion valve, this isn't always the case. On these systems, the refrigerant will pass through a catch tank before making its way back to the compressor to start the cycle again.